and I made this bisection problem uploaded there. So if you download that into and then you upload it to Mathematica system, then it's going to look like this. It's made it very simple. All you have to do is find this run button and hit it. And it's going to generate a problem for you. Let me read that problem for you at this point. E to the x plus x to the third times cosine x. And interval is given 0 to 3. And they sketched it nicely for you. Between 0 and 3, the graph looks like that. So you see it's roughly crossing across to 1.5, and it is asking you to apply the bisection method 4 times to this function and interval and get all these intervals. So I'm going to show you the answer and help you to understand the shape of the answer. Remember, we're not just doing this two number, we're always writing the midpoint as well. So that's how it's written. If you want to look at the answer, you start with a 0 and 3, and 1.5 is midpoint, and you have to figure out the signs of the function values at those 3 points, and we're choosing the second values here, right? And midpoint is 2.25, and because this has an opposite sign, we choose 1.5 and 2.25, and that's the midpoint. You know, that's all written down. So look at the problem, try it on your own, write down the answers, and on 4 of those interval, check your answer, things like that. So there are standardized problem like that. It requires a little bit of practice. I think it's easier for me to sometimes write the code and for you to practice and things like that. So that's one thing. They're all in this standard problems. You can see next thing we're going to be doing is this derivative practice. So it's all in there. It randomly generates functions for you, and you have to find the derivative. You can check your answer. The next thing is this visualization. If you go there, I have another bisection method. These are more of a demonstration purpose. I think I loaded here. This is the same bisection method, but it's not randomly generated. You have a little bit of control in there. It says, instruction says, enter the formula of a function in the line of the command function in terms of x. So here you can type in your own functions in there. It has to be in terms of x. For example, if I want to type cosine, you have to learn a little bit. It has to be in capitalized and things like that. Um, and if it is interval between 0 and pi over 2, I hope it does it numerically. So if you write it down, and everything else has to be done mechanically. So if I run it, as you can see, it changed it to numerical value, and here's the picture of cosine x minus x and 0 to pi over 2. And here you can increase the number of repetition. You can use this plus button to expand the control, and here you can use this plus button instead of sliding in it here. So if you want to go 10, and you can slide it here. So here's a 10 repetitions. You can see the bisection method was applied from here 10 times. So this is the left end and right end. This is the midpoint. So you can see the 736 and 739. So we at least know 73 is never going to change because that's the same in left end and right end points of the interval. Things like that. So the other one randomly generates a problem for you, so you can hide the answer and click in the answer and check the answer, things like that. This is more demonstration purposes. So you type in the function and the other remaining setting, and if you hit enter, run, and it's going to show you the result and things like that. So that's basically the use of my Mathematica in there. You download it and just hit the run button, and it does something nice for you.